Here's some more detail on the filtration, reabsorption, and secretion that occur in specific segments of the nephron and collecting system. Filtration only occurs in the renal corpuscle. There is a balance between reabsorption and secretion, and this varies in the remaining nephron segments. Regulation of the final volume and solute concentration is from the interaction between the collecting system and the nephron loops. Again, you have to know the different parts of the nephron to understand what is going on and where it's taking place. In the renal corpuscle, filtration takes place. Water and inorganic and organic solutes come out of the blood. Plasma proteins and blood cells remain in the blood. In the proximal convoluted tubule, glucose, other simple sugars, amino acids, vitamins, ions, including sodium, potassium, calcium, magnesium, phosphate, and bicarbonate, are actively reabsorbed. Passively reabsorbed would be urea, chloride ions, lipid-soluble materials, and water. Hydrogen ions are secreted, ammonium ions are secreted, as well as creatinine, drugs, and toxins. In the nephron loop, sodium chloride ions are reabsorbed, which brings back water. In the distal convoluted tubule, sodium chloride ions are reabsorbed. Calcium, water, and sodium ions are reabsorbed variably. Secreted will be hydrogen ions, ammonium ions, creatinine, drugs, and toxins. And the collecting system reabsorption of sodium ions is variable, bicarbonate ions is variable, and water is variable. Potassium and hydrogen ions are secreted, and this is variable. In the peritubular capillaries, there is a return of water and solutes from the peritubular fluid to the general circulation. In the vasa recta, there's a return of water and solutes from the peritubular fluid to the general circulation. Filtration occurs at the renal corpuscle. The renal corpuscle holds the glomerulus. The incoming afferent arteriole delivers blood to the corpuscle. The glomerulus is a capillary knot. Filtration occurs here. And the afferent arteriole carries blood away from the corpuscle. This is smaller in diameter than the afferent arteriole and elevates the blood pressure in the glomerulus, aiding filtration. The capsular space is between the layers of the glomerular capsule. The juxtaglomerular complex is at the junction of the afferent and arteriole and the distal convoluted tubule. This secretes renin when glomerular blood pressure falls. The mesangial cells are supporting cells that lie between adjacent glomerular capillaries. They control capillary diameter and the rate of blood flow. The glomerular capsule forms the outer wall of the renal corpuscle and covers the glomerular capillaries. The parietal layer forms the outer capsule, the visceral layer covers the capillaries, and is composed of podocytes. Podocytes are large cells with processes or feet called pedicels that wrap around the glomerular capillaries. Gaps between the adjacent pedicels are filtration slits. Materials passing out of the capillaries have to be small enough to pass through these slits. Fenestrated glomerular capillaries contain large diameter pores and filtration slits from the podocytes. This prevents most plasma proteins from entering the capsular space. A variety of factors control glomerular filtration. Number 1, the glomerular hydrostatic blood pressure. Blood pressure in the glomerular capillaries pushes water and solutes out of the plasma and into the filtrate. This pressure is higher than other capillaries due to different diameters of the afferent and efferent arterioles. Blood colloid osmotic pressure. This is pressure due to materials in solution, and it tends to draw water out of the filtrate and into the plasma. That is, it opposes filtration. Capsular hydrostatic pressure opposes the glomerular hydrostatic pressure. It tends to push water and solutes out of the filtrate and into the plasma. This results from resistance of the filtrate already in the nephron. The net filtration pressure is the pressure acting across the glomerular capillaries. It represents the sum of the hydrostatic pressures and the colloid osmotic pressures. So there are a lot of different pressure interactions here. Podocytes are part of which of the following? The visceral layer of glomerular capsule. The glomerular filtration rate is the amount of filtrate produced by the kidneys each minute. Each kidney has 64 square feet of filtration surface. The glomerular filtration rate averages 125 mils per minute, or 180 liters per day. 99% is reabsorbed. There are two interacting levels of control to help stabilize the glomerular filtration rate. Autoregulation is at the local level, and central regulation includes an endocrine response initiated by the kidneys and a neural response that involves the sympathetic division of the autonomic nervous system. If homeostasis is disturbed, the decreased glomerular filtration rate resulting in decreased filtrate and urine production. This results in autoregulation or dilation of afferent arterioles, contraction of the mesangial cells, and constriction of efferent arterioles. This should increase the glomerular filtration rate. And restore homeostasis. If autoregulation is not enough, then central regulation is involved. The juxtaglomerular complex plays a key role in coordinating responses to decrease the glomerular filtration rate by initiating the renin-angiotensin-aldosterone system, or RAAS. If autoregulation is insufficient to restore normal glomerular filtration rate, the endocrine response is that the juxtaglomerular complex will increase production of renin. Renin in the bloodstream triggers formation of angiotensin 1, which is then activated to angiotensin 2 by angiotensin converting enzyme in the capillaries of the lungs. Angiotensin 2 triggers a neural response. Angiotensin 2 triggers increased aldosterone secretion by the adrenal glands, and angiotensin 2 constricts the peripheral arterioles, further constricting the efferent arterioles. Renin directly activates which of the following? Angiotensin 1. Reabsorption predominates along the proximal convoluted tubule, or PCT. Reabsorption in the PCT includes 99% of the glucose, amino acids, and other organic nutrients, sodium, potassium, bicarbonate, magnesium, phosphate, and sulfate ions, and water, about 108 liters per day. The solute concentration of the tubular fluid decreases and water moves into the peritubular fluid. Whereas reabsorption and secretion are often linked along the distal convoluted tubule. Movement and of water and solutes out of the peritubular fluid into the tubular fluid. Only 15 to 20% of the initial filtrate volume reaches the distal convoluted tubule. A combination of reabsorption and secretion in the distal convoluted tubule alters solute composition in the tubular fluid. Sodium ions are reabsorbed in exchange for potassium ions. These pumps are stimulated by aldosterone. Hydrogen ions are secreted in exchange for sodium ions to increase the pH of body fluids. Carrier proteins also secrete toxins and drugs. Countercurrent multiplication is an exchange between the limbs of the nephron. The thin descending limb and thick ascending limb are close together and separated by peritubular fluid. The exchange between these adjacent limbs is called countercurrent multiplication. Countercurrent means the fluids are moving in opposite direction. Multiplication means the effect increases with fluid movement. This is responsible for creating a concentration gradient in the renal medulla and enables a highly concentrated urine. The nephron loop has a thick ascending limb that actively transports sodium and chloride out of the tubular fluid. It's impermeable to water. Tubular fluid solute concentration decreases, and peritubular fluid solute concentration increases. Osmotic concentration of peritubular fluid is increased from the activity of the thick ascending limb. The thin descending limb is permeable to water and impermeable to solutes. Water moves from the tubular fluid into the peritubular fluid by osmosis, and the tubular fluid solute concentration increases. Water is reabsorbed from the tubular fluid along the distal convoluted tubule and collecting duct. This increases the concentration of solutes within the tubular fluid, particularly urea. Tubular fluid reaches the papillary duct, has a typical urea concentration of 450 milliosmoles per mole. I think it's milliosmoles per liter.